So when you look out of the window, you saw the wall that was horizontal. I'm sorry, vertical. And then there was a horizontal plane that created the roof for the little shelter of when the people come out of the door. And then at the top were cables. I want you to draw only one of the cables.
Oh, I understand. Wow. Because it's like from a side view. Oh, that is way too.
Now, once you have that drawn, I want you to take your patty paper and place it over your triangle. Draw your vertical line. You don't have to draw the entire vertical line. You can draw it short. And then draw the first cable that you have on your paper. This diagonal line is hypotenuse. Now, this line is going to become the transversal. Here's what we're going to do. We're going to take our angles. You see the X on your patty paper, right?
Yeah.
And you are going to translate or drive down this vertical line and stop. Boom. All right. After you have translated a bit down that line, I want you to trace over the image that is on your patty paper. You're trying to make an impression onto your white paper. And after you make that impression, you can look clearly and draw that second line parallel to the other one.
So you just go down smaller? I think I understand it.
No, we didn't make it smaller. It's the same size. We just translated.
What? Oh shoot! I get it, but I'm really tired triangle. Like I feel like you're just like long. First long.
Okay. After that part, I need to show you something and I need to move on. So I want you to hold your hands up like so. We have another chance. All right. Here's how this will go. Let's look outside and we saw parallel lines. I don't want you to ever see a parallel line. But the sad thing is you probably won't see this again until geometry. So here we go. Parallel, 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 perpendicular. Perpendicular. Let's do it again. Parallel, 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 perpendicular. All right, guys, so go. Parallel, 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 perpendicular. Perpendicular for a 90-degree angle.
What about are these?
So this is the perpendicular.
These lines that we have are parallel lines. They're going like this. Now, parallel lines, listen, have the same rate of change. They have the same slope. They will never intersect. The symbol for parallel looks just like this.
It's equal.
Okay? It's an absolute value bars with nothing in the middle. They're dense. Okay? Nothing there. All right. Remember that and let's continue. All right, so look. We had this line. We translated them on here and we created the second line. So now we have two parallel lines. Everybody okay with that?
Yeah.
This line is called a transversal. You don't need to know that for anything right now, but it does have a name. Okay, now I am going to use my handy dandy protractor and I'm going to tell you that the measure of this angle is approximately 43 degrees. Don't worry about it. If the measure, oh, I said 43, okay? This is 43 degrees.
Wait, do we have a portrait? Do we get a portrait?
No, don't worry about it. Just put 43. Look, if this angle is 43 degrees, if I rotate, that vertical angle is also 43 degrees.
Parallel.
Congruent. So, 43 here, 43 here. This is, okay, this is angles on a line right here. From here to there. It's like a half circle. What is the supplement to 43 degrees?
40.
No, this is a half circle.
86.
Why 86? No, from here to there is 180 degrees. You already have 43. How much is left over?
That would be 123.
That's too much.
137.
137 degrees. So, if this one is 137 right here, we can rotate it around, and that vertical angle will also be 137. So 137 right here. Show me vertical angles. I said show me vertical angles. What are y'all doing? That's parallel. Show me vertical angles. What's true about vertical angles? Oh my gosh.
They're congruent. The Jordan are always congruent.
Show me vertical angles.
They congruent.
What is true about vertical angles? Vertical angles are congruent. Try it again. Show me vertical angles. What's true about vertical angles?
Vertical angles are congruent.
Oh yeah?
Yeah.
Show me. Parallel. Show me.
Parallel. Perpendicular.
Okay, now, remember we had this patty paper and we drew this angle and then we translated along this line. With that in mind, I want you to make sense of what I'm about to write. If this angle is 137 and I translate along this line, this angle becomes 137. This one is,
43.
this one is,
137.
and this one is.
43.
Okay, now, I ask you not to talk if it's not important. Parallel, parallel. That's the line, that's the symbol for parallel.
What about
Proportion, perpendicular is an upside down T. Congruent is a squiggly line with an equal sign under it. All right, now, these angles have names. So let's draw another one. Another set of parallel lines crossed by a transversal. Number them. 1, 2, 3, 4, 5, 6, 7, 8. Stop the sound. No sound. I'm going to tell you that the measure of angle 2 is 115 degrees. You have to find the measure of angle 1, 3, 4, 5, 6, 7, and 8.
Wait, which one?
Wait, we're trying to get the 180, right? Yeah.
What is the supplement to 115 degrees? In other words, yeah, 65.
67.
I'm gonna put you out of here. All right, angle 1, 65. Angle 3, 115. Angle 4, 5, 6, 7, 8. I hope y'all right. 65, 65, 115, 115, 115, 65. Okay, now I have to let you know that these all have names and that there are special relationships that exist when parallel lines are cut by a transversal. For example, if I say angle 1, what would you say to go with it? Give me another angle.
Angle 4.
Okay, 1 and 4. Using that same relationship. 2 and what?
3.
5 and
8.
6 and
7.
all right, these are all vertical angles. Vertical angles are congruent. Now we're gonna do another set. All right, 1 and all right, let me help y'all out. 1 and 5. All right, I said 1 and 5. What are you gonna say? Wait, here we go. 1 and 5. 2 and 3 and 4 and all right, those are called corresponding angles because they're in the same position. Corresponding angles. These are congruent. These are congruent. Let's do another set. 4 and 5. What's the other pair?
3 and 6.
Very good. 3 and 6. Notice 4 and 5, 3 and 6 are on the inside and they're opposite each other. They are called alternate interior angles. They are congruent. Congruent, congruent, congruent. We're missing one more set. I wonder who can tell me what it is.
1, 2, 7, 8.
Close. Alternate exterior angles.
Oh, 1, 2, 7.
Not 1 and 2.
Oh. 2, 8, 1, 7. 2, 3.
Not 2 and 8.
2, 1, 7. 1.
Not what? What did you what did you say, Melina M?
2, 7, and 1, 8.
2, 7, 1, 8.
Right, they have to cross.
Angle 2 and angle 7. Angle 1 and angle 8. These are alternate exterior angles. And they are also congruent. If they're on the same side or if they're next to each other, they are supplementary angles, like 7 and 8. Even 3 and 5. 3 and 5 are supplementary angles. 4 and 6 are supplementary angles. If they're next to each other or inside, even same side, what is that? Same side exterior, same side interior. I sound like a doctor. You know, that's how doctors talk when they're like doing surgeries. So like, hand me the scapula. No, 1, 2. No, port 8. And you're like, what? Yeah. So look, same side exterior, same side interior. Supplementary. Same side exterior, same side interior, supplementary. All right, open your devices. I need to make sure you can get into Delta Math. Come get your device, baby. Ronan.
I know.
Okay, open to Delta Math. I need to make sure you can get into the assignment. You're going to do lines and angles first. And then you're going to do angles too. If I have to reset your password, it is going to be math with a capital M, ABCD, 1, 2, 3, exclamation point. Also, if you have not joined Delta Math, go to the class info document and scroll down to October 17th to join.